So I have this little thing. So yeah, the SSZ walkthrough. First, like why? Because it has been a lot of code and stuff, but the overall idea is the SSZ is the backbone of almost everything we do in Lodestar, especially the state transition and proxy, block processing, a lot of things. And we have built a lot of techniques and things in Lodestar to make things faster. We have different thresholds. We have to go in fast enough to keep up with the chain. For example, if we have an epoch transition that takes longer than 6 seconds or 12 seconds, we cannot follow the chain. If we process blocks too late, we cannot process the chain. If we process blocks too late, we cannot propose. So getting to this point has been a lot of work by all of us in figuring out optimizations and better data structures and a lot of iteration to go to the point where now we have processing block times of about 50 to 100 milliseconds and epoch transitions of about 2 seconds, which other clients can do much better, but this is good enough for us to follow the chain. However, we have done a lot of these optimizations in Lodestar side, which make the whole code extremely complicated. There are layer upon layer of proxy of things which have piled up. And the whole idea of this SSZ refactor is, can we upstream all of these good ideas and maybe even more into making a library that transparently gives you really high performance without having to do all this crazy shit. So that's the whole idea. Also making it type safe. There was a PR I think I did a year ago with an idea to do that, and this one does it, because now SSZ is a bit happy about what you do with the types and what you get then. Another big thing that this is an idea from Teku is walk the tree only once. We used to do this trick in some places, but it was very clunky because we had to do it manually. But now you get this by default. So when you read the tree or when you set the tree, every path is walked only once. And then just a good excuse to optimize everything, especially serialization and deserialization with a bunch of tricks. Some of them, like Ginger already found them, but it's good stuff. So I think for the key part, what people is concerned is how is the API? So how do you consume this thing different? And probably the biggest change is on this thing called ViewDU. So what the hell is a ViewDU? We had a session with Kaiman to come up with names, and we got this one, and I think it's pretty good. Just to check, can you see the code? Is it legible?
Yep.
Yeah.
Yep. Got it. So a ViewDU is a tree view with a deferred update. So in SSZ terms, a tree view is some data structure that has a tree as an underlying data. And this one specifically, if you do some change, like setting an element or setting a field, this update will not be committed to the tree immediately, but it will be cached somehow. And then whenever you actually want to do that, you call a commit function, and the tree is updated at once in some efficient way. What we had before was a regular view, which we still have. And every time you do a change here, the change would be applied to the tree immediately. This makes things much simpler. So it's kept for experimentation and essentially any other case that doesn't need crazy performance like Lodestar. A view makes sense. It's more intuitive. But for us, the ViewDU is the game changer. That's where the fun thing is happening. And yeah, as I said, this idea is from Teku, so acknowledge to them. But definitely the implementation is different because we can do it better in terms of memory. So let's take an example. We have an array basic. An array basic is a type that represents a list or a vector. If well, I think everyone is familiar with SSZ, but a list of a vector is a collection of things that have a length, in the case of list, and basic is because it contains a basic type. It's really important in this case because things that are of basic type can be packed in a single node. So reading and writing to them uses some tricks that makes things way more efficient if you don't do these assumptions. So the way this type works, if we go to the view DU, is we have this 3 view DU. Let's walk, for example, through the set. So we want to set some value at an index. And in this case, we have some data structures that help to do this commit and caching things. First, we have an array of nodes. So again, remember, this is a tree view, so it has an underlying tree behind. It has the root node here. And if you want to get some node, what we used to do before is walk through the tree, which is not great, it takes some time. To get around this, what we did as an optimization in Lodestar side is use a mutable vector that was bundled in some other data structure that had the tree for sets and this mutable vector to get faster reads. What we have now is this flat array of leaf nodes. So if you want to read a node, a specific index, you would go to this array first, and then you have really fast reads. In the case of set, for example, this is what we see here. We get the nodes if it's there. Otherwise, we go and fetch it from the tree. Then we clone this node and we set to it. So in this case, what is a bit different from what we used to have in Lodestar is that the mutable vector had an array of values, but in this case, we have an array of nodes. And whenever we do changes, we apply directly from the node. And because now setting things to the node and doing bit operations with the hash objects that we have are really fast. This is really good. And then, yeah, set to the back node. So what happened here is the tree has not been modified. We have mutated some node that is in this array, and then we have added the index to say that this specific node is dirty or contains some change. If you do this enough of times, you can have an n amount of indexes in this node changes set. And then if we want to commit, we call this function, and we would retrieve all the indexes that are dirty from this set, and we will sort them because this algorithm needs it, and then we will run this function, which is an optimized way of setting some amount of nodes such that we walk the tree only once. And with this new node, then we commit it to the tree and we clear the changes. So essentially, it's this pattern of we have a record of things that have changed or need updating. We gather those nodes. We call set nodes at depth. We get the new node, store the node, and clear the temporal data structures. For array composite, it looks a bit different, but it's essentially the same. We have some data structure that keeps track of what views. In this case, the array composite, instead of having basic types, it have composite types. So these composite types could have another layer of this sort of caches. That's why it calls commit recursively on each one. But the same, gets a node, assigns to the nodes data structure. And then here we call set nodes at depth. We get the new node, clear changes, and yeah, that's it. For the container, same thing, but in this case, we can have basic and composite. So it's essentially the logic of both mixed up. And another important feature is this nodes array is something that we want to keep around to persist this fast iteration. Whenever we clone the state or we move the state around or we progress the state through the epoch transition, we want to keep these caches because we will populate them once and then ideally we want to keep them forever. What we used to do before, and this is a key difference, is we use these mutable vectors, which are extremely good when you have data that changes not often and you want to be memory efficient, because essentially the mutable vector is another tree. The problem is that reads and writes are significantly slower than regular arrays, say 500 times or something like that. So using arrays for things that we read and write a lot, which is here the case, it's extremely beneficial for performance. The problem is that these arrays are not clonable. If you want to clone, you have to copy all the data. So borrowing this idea from Teku, what these tree view do is they just transfer the cache. So whenever you clone, I think it happens composite tree view clone. It gets the new view and it gets the cache from the old view. It gives the cache to the new view and then it clears the cache. So it doesn't do any cloning. It's not anything fancy. It just takes this array, it puts it on the new data structure and clears it on the old one. And this works really well because in Ethereum 2, the forking rate is really low. If everything goes well, if our node does stupid shit, then this forking rate can increase. But if all goes in normal circumstances, we should not have any forking. So this is a great strategy because we have everything. We have very low memory, extremely fast performance. So yeah, win-win. So far, I'm gonna shut up. Any questions about what the hell is happening or what this is about? Cricket sound. Yeah, okay. This thing is so composite type. Yeah. So as I said, composites have this view. A view is a tree view that commits immediately. A tree view DU is a tree view that commits as a deferred update. So composite types are typed this way. B is the value, how they are represented, not with a tree view, but with just regular JavaScript data. TB is tree view, TVDU to tree view DU. So whenever you see, say, byte vector, byte array, this 1, 2, 3, this one is the value, this one is the view, this one is the view DU. So yeah, some edge cases, for example, the byte array is a representation of either a list or a vector of bytes. For example, a root in Ethereum 2 is a byte vector. What happens with data structures is that they, at least in our case in Ethereum 2, they never change. So the decision here has been to make them immutable. And with this design, composite type is really agnostic on what a view and a view DU really is. It could be anything, because all the interactions with views and view DU will go through the type. You will never go to the view DU directly and do commit. You can, but the types themselves will go through types. So in this case, the composite type, the view DU, is the byte array. So uint array, the view the same. So yeah, just be aware, manipulations happen here. Some types like the byte array don't have PDUs. And this is really comfortable because now if you do state.genesis byte or root, instead of getting this funky data structure that is hard to work on, which is what we had now, we had these byte vectors everywhere and we had to do castings, we had to do dot value of as uint array. I'm sure that for Tuyen and Cayman, you would be very familiar with this pattern. Now we don't have to do that because the view and the view DU of a byte array is a uint array. So that's cool. The other thing, type safe, yeah. All of this is type safe, which I think is really cool. I'm not sure if I have any types anywhere, but yeah, if you maybe here. Yeah, if you do this thing, cache or get default view, you have the full type. So here you get the byte array tree view. If you do the du, then you get the byte array tree view du, and if you do value, you get the value. What happened before is that everything was typed as the value, and then it may actually be a tree backed or no, and that was a problem, because we had some assumptions on the state transition that things may be a tree backed or maybe a value, and the type of code that you have to write for one or the other is extremely different. And now, because of the API is different, that's no longer the case. If you try to pass now a state value to the state transition, it will not compile, because it only wants a tree view du and nothing else. In reality, this is, so it's not compatible because the API is different. What we used to have is that all the types, the views, the tree views of all the types tried to follow as much as possible the value. So if you want to have an array, you can do the typical quotation. So let's do an example. Const.
Yeah, I'd say it's one of the hugest differences between the old SSZ. The other SSZ library was built with kind of I would say a priority being trying to abstract away the tree aspect and basically treat trees as if they were native JavaScript objects and arrays.
Yeah.
And because of that, the API did its best to obscure that for you. And even the types tried to allow you to pass things in that, it could be an object, it could be a tree. Well, that may be good for I don't know, a website, but in our case, the performance of a tree versus the performance of a JavaScript object are extremely, extremely different. They have completely different properties, and obscuring those things doesn't add any value. It makes things worse, actually.
Yeah.
And so here we're able to just completely, if there's a different API, there's different things entirely, and there's no way you can accidentally do one or the other.
Yep. Yeah, couldn't put it any better. So yes, as an example,
is it now possible for me to assign a property and a value to a value instead of also basically getting assigned in the preview? Basically, my question is with regard to, again, the caching thing, where I just want to get the caching bytes attached to the object and not worry about whether the tree view is getting manipulated.
So you say
I think the cache is internal to it, so you can just get and set you get and set normally, and then behind the scenes it'll be either using the cache or it'll populate the cache for you on the first get.
No, Mike, this is not the cache of SSZ. I'm talking about basically bundling bytes with it, raw bytes, we wanted to bundle in the request response beacon blocks.
Gotcha. Maybe Lion can show the caching of the root.
Oh yeah. Well, let me do a note and finish this.
Okay.
Is that okay? Just to show how this thing looks in practice. So I just created here a list basic type of Boolean type. The other cool thing is we don't have to type this. This is already typed. This type knows that if you do default value, that's an array of Booleans, which is cool. So it knows this is a Boolean. You don't have to, like we do before, phase 0, yada something. Not necessary anymore. All the types are self-derived. Then for lists, if we get the default value, this is a bool array, you can do your bool things here, like index like this, which you can do with SSZ now. But if you get
So
a
default
preview,
default value is an actual array. Remember, it's not a tree view or anything. That would be
Yeah.
default view or default view to you.
yeah, exactly. So list type default view to you. And now here we cannot do this. This is not okay. If you wanna access the array, you have to do get and then the index. Or if you wanna set, you have to do set and then the value. This is a game changer because now we don't have to do proxies. These things are as fast as possible, like same speed as this. So it's cool, but the API is different. So now we have to change everything, but it's okay. Actually, all other implementations of SSZ for either Lighthouse, Teku, or whatever, arrays are done this way, so it's fine.
I have a question.
Yeah.
Because you mentioned in the beginning or sometime talking about that the DU means deferred update, and you said
yes.
It's cached and then you need to like do a commit before it's actually persisted. So in this example that you made, when you set it, you haven't done the commit yet, right?
Correct.
Okay, so if you now want to commit it, then there's a call somewhere that does.
Yeah, so if I get the node, that node does not contain this data.
This changes, okay.
Then if I do commit, this node has changed and this is the new node with the data.
Gotcha.
So I've implemented a few guards because, I mean, this thing is a bit, if you forget to do commit in some places, things break in really unexpected ways.
Exactly.
So yeah, in the tree view DU abstract class, which is how most of the tree views work, if you do hash to root, it will auto commit for you. If you serialize, it will auto commit for you. Because yeah, without this one, I had some funky errors in the spec test that I didn't understand what the heck was going on. But yeah, so at least this. So just be aware, if you do strange things, please commit. But if you do hash to root or serialize, which is what normal usage would look like, then you are covered by this. Because I think there is no situation absolutely ever that you want to serialize something without committing first, because you will just get the wrong data.
If in the first default value, now that you are changing, assigning the 0th element as true, so is it changing the tree as well?
So the first one, this is
yes,
not
line number 17.
This is not a tree view. This is just a regular value. So it's the
no, but if I get on line number 19, the tree view, will that 17th change will be in it or not?
So know that this is a different structure than this one.
Oh, got it.
So to make this complete, we could do here the tree view.
That's default is a constructor, sort of a constructor.
Right.
Yeah, it's
getter
a
functions.
Yeah, so I think I did getters because I think it looks nice. But if you do get value 2, then this is a separate instance from this one. So you're not mutating the original default value. You're just saying, give me the default value of an instance of the default value of this type. So if I do bool TVU, no, this is the new one. So I don't need to commit this one. But actually I cannot, because this one doesn't have a commit, because it's a different type. So any more questions on this or crickets?
So for the default view, you don't have to commit, right? But for the default view DU, you have to commit.
Yes.
And practically for speaking for Lodestar, we're probably only ever using view DU and the value representation, right? The native JavaScript representation, right?
Yes, yes, we don't use this anywhere. Or we will not. Maybe
So
people
what
for
will happen
groups.
if I do type of bool array, array, and the type of list type? Just wondering.
So yeah, list type is an object. It's a huge object with a bunch of properties. I'm not sure if I can I run this? Regressions. Have a terminal. Nodes, and we are in test unit regressions. So this thing. So this is the type. It contains essentially here information about what's the type about, the element type, some characteristics about depth, default length, yada yada, and then a bunch of methods that will not show here, but about how to manipulate the type, serialize, serialize to 3 from 3, a bunch of things. Then the bool array, it will be just a boring array of booleans, and maybe to show these ones, the 3VDU, it will be another very complex object with a bunch of things. And the node and the type. So the bool array, a boring array of booleans, and the 3VDU is this thing, is a class that has a reference to the type, same thing that we saw before. The root node with uncommitted data, and then the caches. So nodes change dirty length, nodes length, and these things.
And the bool tvdu.node, that's a getter that returns the root node.
Yes, exactly.
Okay.
Easy. Just this thing.
Maybe we can call it root node. I don't know.
Or call the root node.
Yeah.
It's fine. Yeah, I like to call it root node internally because there are some functions that deal with nodes, and then if the root node is also a node, it's a bit confusing. But externally, like this thing only exposes one single node, so it makes sense to just call it node. But yeah, I mean, since we want to eventually go to 1.0.0, it will be great if you have suggestions for refining the API, essentially better naming. I did my best, but it's really hard. There is a lot of things and a lot of methods, and it's very confusing. So if you have suggestions and you think things are confusing, please let me know, and I will think of better names or something. So, okay, I think we can look into the caching of the object. So what Kaiman mentioned is right now in Lodestar, we use for blocks, attestations, and aggregates 3view, but not because we really need the 3view, only because we need caching of the roots. We hash the attestations once on the wire to compute the message ID, then we hash them again to verify the signatures, and then we hash them again to use caching and a bunch of other stuff. So if we don't cache the roots, we will hash the object 3 times, which is expensive and a waste. But now we are using the views, which are much more memory, so cost way more memory and are much lower than just a regular value. So what I added in here is for composite types. Where is it? This thing. So if you do a hashtag root of composite, if you set this thing to true, which is a parameter that you can set on the type, so we can say we want to cache the roots of any attestation data. What it will do is just compute the root and then shove it over the object. So assign the root to the object at some symbol. It works, it's very cheap. It just essentially attaches information to the object and it's recycled above. So we can still use objects. This thing is cheap, doesn't take much memory, and then we don't have to use views. But it's very rudimentary. It's just shoving things into objects.
And there's still ways you can screw it up if you update the value, update the object. And this is basically where you're assuming that the object is immutable, right? That
yes.
The hash tree root will never change.
Yeah, if you call hash tree root, so if you have cached permanent root stroke true, you call hash tree root and then you change the object and you call hash tree root, you will get the wrong root. And there is no way to unset the root, so you will have the same root forever.
Unless you somehow know about the symbol and manually delete the the value at that symbol.
It's not exported, so you cannot do that.
Oh,
because I think that if you call this function again, you will not get the same symbol. I think when you pass a text is only for debugging purposes, but it will not be the same.
I see.
So yeah, it's a dangerous feature if you don't know how to use it properly, but if you use it properly, it's extremely powerful.
In our case, I mean, it's not a problem. Really, what it's going to allow us to do is it's going to allow us to represent all of the blocks and attestations as JavaScript objects instead of as full trees. And it's going to speed up all of the gets and sets while still allowing us to have the hash tree root cache.
So this cache will be available at all levels, basically block.message dot something, right? Sign block.message.
No, the idea is that we will set it to specific levels that we want, but it will be off by default everywhere.
So how do we set that to a specific level?
We will have to go, for example, station data here and say cache permanence true.
Okay, so basically it's like a casing map kind of a thing, which only works at this level and it can be nested as you want, right?
Yes. Oh, and a fun side note, I replace all your manual casings, and sorry about that, for this thing that works as well, and then it's much less verbose, which
okay, sounds good.
Yeah, it's essentially the casing from the library we have, but with a few tweaks such that the stupid casings that Ethereum 2 has work, and then we can just do this and it's fine.
So,
but it will run casing transformation, or it has that map already set somewhere?
Sorry, could you repeat?
I mean, for example, if you do to JSON or from JSON, will it run the transformations in the library, or will it basically you have a ETH2 map somewhere? I mean,
right. So the containers have a JSON key to field name mapping pre-computed at constructor time, and you cannot change that.
Oh, so understood.
With the options that you pass, so essentially all the containers have a key map, but the difference is that it's computed in the constructor. You don't have to pass it. That now you have the same speeds and the same immutability in casing, but you can say some options. You can still pass the casing map, or you can ask for it to be generated with the ETH2 JSON casing or something.
Understood. And I'm still wondering about how to bundle bytes with a tree view. I mean, bytes which, so basically take a tree view, take a delegated tree view and not commit. I mean, add bytes to it and not commit. I mean, this is how you think it should be done?
You mean for the request and response issue that you want bytes, right?
Right. So when I want to bundle bytes with the tree view block, but then I don't want anything to happen to tree view.
Keep in mind that the block will not be tree view anymore. It will be a value. And what Cayman was proposing is that you can just assign the bytes to the block. If you have the block here.
Okay, so basically it will be, yeah, okay, understood. So instead of it being a tree view, now it will be normal bytes with the cached root.
Yes.
Right. And if it was a tree view is just an an instance of a class now. It's no longer a proxy. So you would also be able to do, you should be able to do the same thing.
Right. Though I still think that for this thing you should use a weak map.
Oh, right.
I'm not sure, but you should, because so the thing is, we have a single instance of Lodestar that will keep track of everything. So maybe the weak map makes sense. Like the problem with the weak map is that you have to keep this instance around. But I think for our case that's not a problem, because we can totally do that. I'm not sure. We'll have to see how the implementation looks like. So
right. So once basically it is just a normal value, then it's pretty easy. There is no tree getters and setters involved. That would be cool.
Yep. Cool. So any other questions on this, or can move on? Crickets. Let's go.
I would highlight the proxy list types, just as I don't know if he's mentioned that.
Yeah. Well, as I said, we had to use proxies before because we wanted to have this API of arrays acting like arrays. But now that we use get and set, we don't have to. So we just don't. And it's a regular class that has a method called set and a method called get. For the other one that we needed are the objects. So if you want to do state.genesis or something, we use the proxy for that. But what I did here is just use the old object defined property where you can assign a custom property to the prototype of a class. And whenever this constructor gets run, you will get an object with custom properties that have been computed dynamically on runtime, but are acting like if they were regular properties, so as fast as a regular object. And you have the proxy-ish thingy of defining things at runtime. So I think that covers it. Or Cayman, what should I say something else about this?
I think that's perfect. That was what I was hoping you were going to cover. Yeah, there's no more. You don't have to worry about, if you're calling, whatever your object dot something, that there's going to be some trap that gets triggered, and then now it's it's going to be interpreted in some weird way. It's like, no, you just have methods, right? You just have normal methods and normal properties on objects, no proxies anywhere.
Right. Cool. What else? Yeah, couple fast side notes. So for the bit arrays, so bit vector bit list. A bit vector is what we have, for example, for the aggregate attestations, the aggregate bits. A bit list. Oh, that's a bit list. Anyway, so for bit arrays, what we had before was a Boolean array, but now this is using a custom implementation of a bit array, which is a class that has a unit array instance and is aware of the bit length. This is a classic computer science program trade-off decision where if you have Boolean array, you have extremely fast reads, but it just takes 8 times more data. The thing is that Tuyen came up with this awesome idea of caching all the possible Boolean arrays for each byte value. And with this data structure cached, you have exactly the same performance with unit arrays than a Boolean array. The problem is that we were using that only in Lodestar and only for tree view, but now we use it for everything. So everything is a bit array, everything is really fast and takes very little memory, and it's super fast to deserialize because you're just taking the bytes from the binary blob and shoving into this data structure. So it's awesome. The other
so
thing,
like if you were just to do default value of like a beacon state or something, or of an attestation data, when you got the data dot, what is it, when you got like the bit list there, it's going to give you a bit. It's not going to be an array anymore, right? It's going to be a bit array object.
Yes. Yeah, let me demo. So phase 0 attestation data default value. If you do attestation data, oh no, it's a aggregate and proof. Aggregate enrichment bits. This is a bit array, and this has a lot of fun things. Get single true bit, get true bit indexes, intersect values, intersect just values, merge or widths, which is really fast bit operations that we used to have in Lodestar. Now they are here. So yes, the whole idea of upstreaming these really cool optimizations that have been done over time on a single thing that's nicely encapsulated in the API. Cool. So yeah, let me go fast. It's getting late. Other important thing you must be aware of. We have this really funky thing, which is the container node struct type. This is a container type that when it's a tree view, it's actually a struct, but it's a tree view. So it's a node that has a struct value. So a struct is the value that we are talking before. This is absolutely critical for Lodestar performance. Like this was a game changer because the validator objects, we almost never update them, but they just take a huge amount of memory. And with this thing, they don't. So yeah, just be aware this exists. It makes everything much more complicated, but it's much faster and nicer in memory. I think the key thing is this branch node struct, that it has a value. So yeah, I'm not gonna go into detail. If you're curious, we can talk another day, but just be aware this exists and it's important. And I think the last thing I wanted to show is that like this thing is massive and test coverage is really key. So I went all in on dynamic testing. So for example, for unit tests of types, they are all organized by type. So for example, container, we have valid, tree, invalid, and for valid, there is this function that you can say, I have this type, and this type has these values, which some name, serialize this way, JSON this way, and root this way. So it's kind of essentially a spec test, but done as a unit test. And this function does a lot of things. So tests, run valid test. Yeah, it does type equals, type serialize, type deserialize, type serialize again from the roots, history root, value to tree, serialize size, tree to value, deserialize from bytes tree to view, to view, get node, get back node, a lot of things. And this gets done for that type and also this type. So you can, in very few, like just writing 4 extra lines of code, you have maybe 30 extra tests for this data. And yeah, I think this, at least for me, developing this has been a game changer. So probably gonna do that more in the future. And I used to miss the fact that you can maybe comment or solo the things, but the API of Mocha is insane, and I'm not using it enough. I'm not sure if you knew, but you can do Mocha --ref and pass a reg expression. So if there is some test like SSZ static invalid 1, and then it will only run this test, and you don't have to solo or skip or only, you don't have to do any of the cheat, you just do grep and that's it. You can also do bail, and it will run all the tests, and whenever there's an error, it will bail and stop. So you can focus on one test at a time. And all of this is built in, it's super useful. So yeah, that's cool. And also for the tree ops, it's the same, like programmatically define a bunch of tests with the least amount of codes possible. In this case, I'm saying, this is the value before, this is the value after, and this is the function that does the mutation to get this. And behind the scenes, it's doing a lot of tests. So it's testing as a value, as a tree, as a value, going from one from the other, serializing, has to root, everything I could think of for everything. And even I think I went even as far as here, where is this run view test composite swap. So given a value, so given a type, give me 2 values, 1 and 2, and then I would run the 3 view test mutations on containers. So take container with A and B, and then you put one property, then the other, and then you swap them. And then for list types, vector types in array and composite, in basic and composite, and the same, just property 1, 0, then swap and test the whole test of things. So yeah, just think about it. I think this dynamic testing is absolutely massive, and we could increase our test coverage by a lot without going crazy, because some tests that we have in Lodestar are ridiculous on how many lines of code they take and how little do they cover. So at least good stuff. And yeah, it's pretty late. I think I'm gonna shut up for now. If you guys have any more questions, shoot them in.
Awesome, thanks, Lion. Is there anything that is in this presentation that you don't want to show? I was thinking of actually just making a video of this and posting it as well for you guys and potentially anybody else that's looking into SSZ.
No, I think that's cool. If
Okay.
they don't mind me coursing or saying stupid things, it's not a problem.
It sounds like a them problem. All right. Any last minute points, questions for Lion? If not, thanks for doing this, Lion. And I'll, instead of the crickets, I'll just give you a clap instead. I mean, do some clapping. For the crickets.
Thank you.
Thanks for
Amazing
that.
work. Lion.
Yeah, if you want, you can give the PR a review. It's 14,000 lines and growing. So just, I would recommend giving the review now, because maybe tomorrow it's at 15,000.
Number go up.
Yes, very, very important.
Awesome. Thanks, Lion. If that's it, then that concludes the stand-up, and we'll see you guys Friday, and I'll shoot up a link for the video once it's up.
Awesome. Thank you. Thank you everyone for staying.
All right. Thanks. Bye-bye, everyone.
Thanks,
Yes,
Lion.
Bye, everyone.
Bye.
Bye.
Bye bye.